later, so it'll be all good.
Oh, how alone? It's like a homeschool birthday party where it's just you.
Yeah, basically.
All
I'm
right.
I'm just gonna put the link on Instagram and see who joins.
You that sounds like an idea that could be great or terrible
Yeah, we'll see.
based
That's what that's just what I want to see is how it turns out.
based on who pops in.
Yep.
Okay. Well, back on tangent. Let's do this problem. So it's going to be taking a limit, but the catch is we will restrict by using Taylor series to evaluate the guy.
Okay.
And it'll be the limit. Let's pick a good one. Oh. Well, that one doesn't look too bad. Of 3 times arctan of x minus 3x plus x cubed over s to the 5th. For everyone who has popped in, which is Luke, Matthew, and Unique. Our first problem is using Taylor series. Want to evaluate that limit in the box. So I know we can use L'Hopital's rule to evaluate that guy, but now I'm saying let's try to use some Taylor series to evaluate that. So
There's a homework problem in our quiz like that.
yep. And this is probably one of the most common problems of working with Taylor series. So I want to make sure we're on the same page with it. All right. I'll give y'all until 3:40 to work on it. And again, y'all know the drill. If you have a question, either unmute your mic or like Anthony, unmute your mic like Anthony and state your question or post it on the chat. Let's see. Looks like Isaac just joined us. So to give you context, Isaac, what we're doing is using Taylor series to evaluate that limit. If you have a question, unmute your mic or put your question in the chat. Oh yeah, I agree. Let's have some fun. You're close, Anthony, but it's not quite 1/5. Alrighty. Give you all about 2 more minutes to work on that. All right, give me a status report, y'all. How's that problem going? All right. Thanks for the update, Isaac. How about anyone else? Anthony, I got your message. All right. In that case, I'll give y'all about another 2 more minutes to work on it, and then we'll go over the solution. All right. So with that, let's go ahead and talk about the solution for it. I'll let you know that Anthony's answer 1/5 is right. Let's see how we get there. First, what's the Maclaurin series for arctan? What terms will I get in the Maclaurin series for arctan? We sum k goes to 0 to infinity. but what should go inside the series? Give you a minute to type that down and let me know while I take a sip of my tea. There we go. Thank you, Anthony. That's to the 2k plus 1 over 2k plus 1. Fun fact. I got you. One quick way to remember the Maclaurin series for arctan is it looks very similar to the Maclaurin series for sine. The only thing is I don't have a factorial in the denominator. So if you want a quick and cheap way to remember the Maclaurin series for arctan, there's your quick and cheap way to remember the Maclaurin series for arctan. It's essentially the Maclaurin series for sine, but no factorial is appearing in the denominator. All right, so let's tackle this bad guy and see what's happening. Limit as x goes to 0 of 3 times arctan of x minus 3 x minus x cubed over x to the 5th. Well, now that I have the Maclaurin series for arctan, I'm going to substitute that in. So the limit x goes to 0, 3 times the Maclaurin series of arctan, which is the sum from k equals 0 to infinity of -1 to the kth power, x to the 2k plus 1 over 2k plus 1. And then I minus the 3x, and then minus the x cubed, all divided by x to the 5th. All right, well, that's nice, but let's try to expand out that series and see what stays alive and what cancels out. So that equals to the limit as x goes to 0. Because I have that x to the 5th in the denominator, one thing that I like to do, move that x to the 5th out front as 1 over x to the 5th. And note that at the end, I will have to distribute that later. So I get 3, and if I expand k equals 0, plug in 0 for k, I'll get x. Plug in 1, I'll get a negative. Plug in 1, in the exponent, I'll get 3, and the denominator, I get 3. So I'll get x cubed over 3, and k equals 2. I'll have -1 squared, which is a plus. Then I'll have k equals 2. In the exponent and denominator, I'll have 5. So that's to the 5th over 5. And then the pattern keeps going where from 3 and then 5, my exponent and my fraction will just increase by 2, and I alternate between plus and minus. Dot, dot, dot. Then I have that minus 3x minus x cubed going on. X cubed. There we go. Sorry about that. Can't read today. All right. So next up, I have that 3 coming into play. So I'm going to distribute that everywhere that I see inside that parentheses. So I have limit as x goes to 0, 1 over x to the 5th, 3 x, after distributing the 3 to that first term, minus s cubed over 3 times 3, but the 3's will cancel, so I'm just left with an s cubed plus 3x to the 5th over 5 minus 3x to the 7th over 7, keeps on going, minus a 3x plus an x cubed. Now some things get to die off. Got a plus 3x, a minus 3x. Those two are gone. I have an x cubed, a minus x cubed. Those two are gone. Meaning what I have left is the limit as x goes to 0, 1 over x to the 5th of 3x to the 5th over 5 plus or minus 3x to the 7th over 7 plus 3s to the 9th over 9 or 1/3 or s to the 9th over 3 and so on. Now because I have that 1 over x to the 5th, I'm going to distribute to each of them. But because that s to the 5th will be in my denominator, all of my everything x raised by a power, that exponent will just get subtracted by 5. So for the first term, the s5 is going away. For the second term, I will reduce, and I'll be just left with a net squared. For the third term, of 3/5 minus 3x squared over 7 plus 3x to the 4th over 9, and then so on. Well, luckily, since we have a Maclaurin series, this whole thing is a polynomial, which means it's continuous, and the limit of a continuous. And we could do something continuous and plug it in, meaning my final answer will be 3/5 minus 3 divided by 0 squared over 7 plus 3 0 to the 4th over 9 dot dot dot. Everything will get 0, and that gives me just left with 3/5. All right, there we go. Let's see. Anthony. Sure, let me look at what 3b is. Okay, yeah, we could do something similar to that. And for the problem, I will write the property that we will be using. Because to do 1b, we will have to use a property from power series. So first, let me get a problem similar. And then I'll list down the property. So that'll work. So the problem that I think will be similar to help y'all out will be the integral. And because we had arctan before, let's use Taylor series again to evaluate the integral of arctan. And the property that I'm thinking of from power series is the following. It's that if I can represent a function as a power series, and it doesn't matter what the center is, so I'm going to make it an arbitrary center. then the integral or the antiderivative means that I can integrate term by term. And the reason why it's nice to integrate term by term is because I'm going to have a lot of polynomials kicking in, which means I could do my reverse of the power rule. So it'll be c to the k, x minus a, k plus 1 over k plus 1. And one thing that's confusing that I don't like in your your calculus textbook, it doesn't have the brackets to denote that that c is not inside the series. So I'll put a bracket around it to make it clear that it's not inside the parentheses for that. And so that's going to be the property we use to evaluate that antiderivative of arctan. And so what I'll do first is I'll do an example for the antiderivative of arctan, and then I'll give you all another one to practice to see how we can play around with it. All right. Oh, that's adorable. I just saw the Zoom chat. Anthony, I'm glad you feel loved since it's your birthday today. Well, at least by James. All right. So, as we know from the previous example, we know that arctan has the Maclaurin series of -1 to the kth power x to the 2k plus 1 power over 2k plus 1 with no factorial. And so with that, if I take the integral of arctan, then that is the same as me saying I'm going to take the integral of its Maclaurin series. The -1 k x to the 2k plus 1 over 2k plus 1, and then a dx at the end. And now what the property is saying is if I'm integrating with the power series, I can essentially move the integral inside and I can integrate term by term. So I'm now going to integrate -1 to the kth power x to the 2k plus 1 over 2k plus 1. And then a dx inside. The -1k and a 2k plus 1 are constants with respect to x. So if I integrate that, I can move the -1k power, the 2k plus 1 outside, and I'm just left with taking the integral of x to the 2k plus 1. And from there, I get to use my reverse power rule, which says I add 1 to the exponent, and then I divide by the brand new exponent. And if I add 1 to 2k plus 1, I will get a 2k plus 2. So I will get k 0 to infinity of the -1 to the kth power over 2k plus 1 times antiderivative of x to 2k plus 1. And because that's x raised by a power, I'm using my antiderivative rule for antiderivative, or power rule for antiderivatives. And that's what that will look like there. And there's our first example of taking an integral with this Maclaurin series or with this Taylor series. Any questions on data sample? Yep, that's the answer. If we have, say, a bound infinity, like if it was a definite integral, then I would do a definite integral in there. But since I don't have a bound on my integral, it just means I'm taking an antiderivative. And I think you probably asked because, let's check. On like I think on MyLab Math, it gave you like a definite integral and it asked you to estimate it. That'll be my guess what MyLab Math is doing. But if you have a antiderivative, then just like a normal antiderivative, we're doing that at the very end. I'm doing it term by term. All right. Any questions on this example before I give you all another one? All right. I don't see anything there. Then I'll give you all one to work on. That will be the integral of natural log of 1 plus t over t d of t. And I want y'all to integrate that using Taylor series. And while y'all work on this, there is one note or one hint that I'll give y'all. Is that for the integrand natural log of 1 plus t over t, when you're finding the Maclaurin series for that, rewrite it like that. Because I say one of them I know the Maclaurin series for, the other term I don't. And so we're going to have to do some rewriting. All right. I'll give y'all 10 minutes to work on this before we go over to the solution. And if y'all have any questions, unmute your mic and let me know, or post your question on the comment and I'll do my best to answer it. For the person who joined, welcome. The problem that we're working right now is use Taylor series to integrate that guy. And if you have any questions, unmute your mic and let me know, or post it on the chat. All right, I see a message, and I will respond to you shortly. right. See that message? All right, give me a status report, y'all. How's this problem going? Heard from Isaac, but how about the rest of you? All right. We got an update from Anthony. How about everyone else? All right. So what we're going to do now is we are now going to solve this guy. First, to solve that, the reason why I gave the hint of rewriting the integrand as 1 over t times natural log of 1 plus t is because the way that I'm thinking of using that, of solving this guy, is I'm going to abuse this property of power series, which is if I have x raised by some exponent m multiplied by a power series, then I can essentially say, oh, okay, well, we're going to move that m inside and add the exponents. And so let's do that with 1 over t times natural log of 1 plus t. So natural log of 1 plus t is one of the more common Maclaurin series. And the Maclaurin series for that is the sum starting at 1, ending at infinity, of -1 to the k plus 1 power times x to the kth power over k. Just clarification about this series. If you go looking for like a chart for Maclaurin series, another representation of the Maclaurin series for natural log of 1 plus t, that's, well, first it needs to be a t and not an x, is some people start this Maclaurin series at 0, and what changes is, crap, go back down there. It's the following. So if you go looking for, say, a chart of common Maclaurin series, and if you see that the Maclaurin series for natural log of 1 plus x is the series in blue, note that they are equivalent. If you've heard me talk about changing where I start off with my series, the way that these two are equivalent is they just define a new variable as k minus 1, which is how they got that. But let's go back to our original problem. Now that I have 1 over t, I can use this property of power series that says I can move the x raised by a power from outside the power series to inside the power series. So I'm going to move that inside my power series to give me the sum k equals 1 to infinity of -1 to the k plus 1 power t raised to the exponent that was inside the power series originally, plus the exponent of this x raised by something that I brought in. And because I have 1 over t, that means it had a -1 power. So that means my new power for t will be k minus 1, with all of that divided by k. So with that, I now have a Maclaurin series for the integrand that I want to integrate. So with that, now we can go ahead and integrate the natural log of 1 plus t divided by t d of t. And that equals to the integral of this brand new series that we have boxed in, the sum starting at 1, ending at infinity, -1, k plus 1, t to the k minus 1 power divided by k, and then we have dt. Now I'm going to move that integrand inside the series and integrate term by term, meaning I have the sum going from 1 ending at infinity, -1 to the k plus 1 over k. Those are constants with respect to t. So the -1 to the k plus 1 power over k is going to be outside of my integral. And I have inside my integral t raised to the k minus 1 power. Now I get to use my antiderivative version of the power rule, which is I add 1 to the old exponent to give me my new exponent, and then I divide by the brand new exponent. If I add 1 to k minus 1, I'll get back k, and then I divide by k. So I have the sum k equals 1 to infinity of -1 to the k plus 1 power over k times t to the k power over k. And note that we have a plus c now since I evaluated the integral. And then I have 2k's appearing in the denominator being multiplied. So I could rewrite that as the sum from k equals 1 to infinity of -1 k plus 1 power over k squared times t to the k power, and then a plus c at the end. And that gives me a very lovely antiderivative for that guy. Any questions on how I did that or anything about that sort? Did you? What is ET unique in your second line? I'm guessing, how did you get the initial equation? So the way that I got the initial equation is I used the Maclaurin series for natural log of 1 plus t, which is the sum from k equals 1 to infinity of -1 to the k plus 1 t to the k power over k. And then I used my property of power series that says if I have x raised by a power, or a variable raised by a power outside the power series, I can move it inside the power series by adding the two exponents together. And so for that 1 over t, since 1 over t is t to the -1 power, that means m in this case is -1. And so when I move that in, I want to add my old exponent to the -1 to give me the k minus 1. So that was how I got my initial equation before I did the integral. All right. Any other questions about this problem or about this example? All right. In that case, I'm going to come up with another example to play with. And as I write that down, if you thought of a question that you want to ask, just let me know as I pick and write it down. So here we go. So I think the good one will be since we now know Maclaurin series and properties of power series by now, one good example now is to identify the function represented by the following power series I'm going to give you. So let's start out with one of them, which will be the sum from k equals 1 to infinity of s to the kth power over k. And so what our goal is we're trying to match what function is married with that power series. And I'll do this one and let y'all work on another one to kind of get the gist of how to do these problems. So when I am asked this type of question, and I'm asked to identify a function represented by a power series that I just see out of the blue, actually, for the sake of this example, let's call this series Joe. Let's say I see Joe walking down Tiger Boulevard, and he decided to chat with me, and I really want to figure out who he actually is. The first thing that I'm going to think of all right, that was actually really good, Anthony. That was actually really great delivery. All right. And what I mean with that question of can I identify Joe in this case with a Maclaurin series is I want to see if, based off the series that I am given, can I recognize a Maclaurin series that is very similar to? That's going to be my first question, is I want to figure out if there is a Maclaurin series that it is very similar to. And so, because I see an x to the k raised by k, well, I know it's not e to the x because I need a k in my denominator. I need a factorial to pop in. Yeah, in this case, I am assuming that the center is 0. If Joe, in this case, decided to look like this, and I'm like, oh, geez, now I got to now think of a Taylor series with the center 1, and that's going to be doable, but not super quick like I want it to. And so with that, let's go ahead and try to figure out how we can do that. Well, here's kind of my thought process. I'm going to look at something that we've just done is I say we have a Maclaurin series that looks very similar to Joe, and that is the Maclaurin series for natural log of 1 plus t. And so I'll go ahead and tell you the Maclaurin series, and I'm going to try to marry it with. But here's kind of my thought process. Because I saw it x to the k raised by divided by k, my thought process is this is similar to the terms in the Maclaurin series of natural log of 1 plus x, which is one of the Maclaurin series that we know a good bit about. And so let's go ahead and write down that Maclaurin series again. It is the sum from k equals 0 to infinity of, let's copy that guy down, negative 1 to the k plus 1 t to the k over k. Or x to the k, all divided by k. All right. So there's one thing that's nice about it. But Joe, he doesn't have a negative 1 to the k plus 1 power coming in. So what that means is I got to figure out, based on knowing what the Maclaurin series for natural log of 1 plus x is, I need to figure out how can I manipulate that to get rid of essentially the negative 1 to the k plus 1 power. And the way that I'm going to get rid of this term is I need to force this to always be positive 1. And the way to force it to be positive 1 is I need to figure out a clever way to make that exponent always even. Because if that exponent is always even, well, negative 1 raised by an even exponent, the negative sign is going to go away, and I'll just always get 1. And so let's do that. So my first trick in the book is always, let's check what happens if I just put in negative inside, meaning what I changed instead of a regular x, I have a negative x as my input. So from our properties of power series, if I don't have just the x just plugging in, wherever I saw x originally, I'm going to replace it by the guy in pink. So that gives me the sum going from k equals 0 to infinity of negative 1 to the k plus 1 power. And because I now have plus negative x, instead of an x to the k, it's going to be a negative x to the k over a k. Well, because I have negative x raised to the kth power, I can rewrite that as negative 1 to the k plus 1 power. And because negative x is just negative 1 times x, I can rewrite that as negative 1 to the kth power times x to the kth power over k. Well, that seems promising because I have two -1s raised by different exponents, so I can combine them together and add the exponents together, which gives me the sum from k goes from 1 to infinity. That needs to definitely be a 1, because otherwise I'll divide by 0 at k equals 0, of -1 to the 2k plus 1 x to the kth power over k. Now here comes my question. Am I done with getting rid of essentially the -1 exponent? Yeah, it still would be negative. I mean, if I plug in 1, I'll get 3. But if I somehow add another -1 up front, then I'll have 2k plus 2, which will always be even. Which means to accomplish what I want, to get rid of the -1 power, I need to multiply this whole thing by another negative number. And then once I move that -1 power inside the series, I'll have sum k equals 1 to infinity of -1 to the 2k plus 1 from before, times another -1 from me moving that negative sign inside my series, times x to the k power over k. And now I get the profit from my work, because now I can rewrite -1 to the 2k plus 1 times a -1 as the sum from k equals 1 to infinity of -1, 2k plus 2, x to the kth power over k. And now I can boldly say, no matter what I plug in for k, I will always get an even power, which means I can boldly claim this whole guy. Oh, that was a mistake on my part, Anthony. The series should start at 1, because if I started at 0, I will have 0 in my denominator when I plug in 0. So I changed my sum equals 0, k equals 0 to k equals 1. So that was a typo on my part. So that's why k equals 1 now, because I can't read. And this will always equal 1, meaning I now have the sum as k goes from 1 to infinity of s to the k over k, which means I now identify what Joe is. Joe is the function negative natural log of 1 minus x. So that's going to be my game plan if that's the type of question I'm asked. I'm going to see if I can marry it with a Maclaurin series that I know. And the reason why I chose a Maclaurin series is because the series I was given had a center of 0, which means I could work with a Maclaurin series. And then with that, I get to play around with that to try to marry it with a variation of the function that I know has a Maclaurin series. All right. And with that, now it's time for me giving y'all essentially the same question with a different series. And so what I want y'all to do is identify the function represented by Yes power series. The sum from k equals 0 to infinity of 2 to the k power times s squared x to the 2k plus 1 power. I'll give y'all about 5 minutes to work on that. And if y'all have questions, let me know. It is sort of working backwards. We're essentially trying to see if I can make it look similar to a Maclaurin series that I know, and then manipulate it to give me what I want. Give me a status report. How are y'all doing on the problem? So quick question. How are y'all doing on this problem? Y'all getting it, or think you have an answer? All right. So, since I don't hear an update from y'all, I'll go ahead and let y'all know the answer. The answer that I got is x over 1 minus 2x squared. Let's figure out why I got that for the answer. So just like before, I'm going to try to marry this guy with a Maclaurin series that I recognized before. And my dead giveaway is I have x raised to something with the k inside there. So that's the Maclaurin series that I recognize. The reason why I'm recognizing it, as I mentioned, is because I have an x raised by something to the kth power, and I'm not being divided by anything else popping in. And so now that I kind of recognize a Maclaurin series similar that I'm going to shoot for, I want to try my best to manipulate it to the best of my abilities. And here's going to be my thought process for that. First thing that I'm going to do is going to deal with the exponent. I have 2k plus 1. For me to manipulate and to transform it into a form similar to the Maclaurin series in pink, I don't need that plus 1 in there. So I'm going to split that up as the sum from k equals 0 to infinity of 2 to the kth power times x to the 2k power times an extra x popping in. Now this x has no k with it. It has no relationship with that index k. Because of that, this x circled is treated like a constant in the series. So I get to actually am allowed to move that outside of my series to get x times the sum from k equals 0 to infinity of 2 to the kth power times x to the 2k. Next thing I want to do, I could rewrite x to the 2k power because of the following property of exponents. If I have two numbers being multiplied within my exponent, that's the same as me saying I'm going to have x raised by the power a, and then for that whole expression, I'm going to raise it again by the power b. So with that, I'm going to rewrite that as x times the sum from k equals 0 to infinity of 2 to the kth power times, and in this case, a is going to be k, and the b will be, or I'm so sorry, let's rewrite that. A will be 2 and b will be k. Now, the reason why I chose k to be the outside exponent is because 2 is also being raised by k in front, meaning I get to abuse the other following exponent power. But if I have two numbers being multiplied together and they're both raised by the same power, that's the exact same work as multiplying those two numbers and raising their product by the power a. Which means I will have x times the sum k equals 0 to infinity of 2x squared raised to the kth power. And so now I claim that I have something similar to the Maclaurin series that I married it with. Instead of x raised by the kth power, I have 2x squared raised by the kth power inside my series. Which means I can rewrite the series as 1 over 1 minus 2 times x squared. Or instead of an x, I'm going to replace it with 2x squared. So I'm going to rewrite that as x times 1 minus 1 over 1 minus 2x squared. And because of that x up in front, I get x over 1 minus 2x squared as my final answer. And there's me working backwards of trying to figure out what the series is in terms of a function. Any questions on data sample in particular? In that case, since we have 5 more minutes, I did want to ask y'all about how I want to do tomorrow. Do y'all want to do more practice problems tomorrow on Taylor series? Or do you want to move on to parametric equations tomorrow? I'm fine with either or. It depends on what y'all want to do.
I mean, I feel like we've covered a lot of the basics. So parametrics would be understandable, but I don't know. Taylor series always help.
All right. So you'll be fine with moving it to tomorrow, doing Taylor series tomorrow, Isaac?
Yeah, that would sound good to me. I do have one more question for the take-home quiz, however.
Either or is good with me.
Okay. Yeah. Everyone else, you can comment what y'all want. Isaac, go ahead and state your question.
Yeah, so I was taking a gander at number 4 today about finding the sum of the following series.
Correct.
I'm just not sure where to start compared to all the other questions that I've encountered so far.
So I actually say, Isaac, that what we were doing is actually going to help you out. So part A especially is very similar to what we just did.
Oh, really?
Yep. So part A is asking us, can I identify that series with a Maclaurin series and try to manipulate it to fit into that form?
I see. And then finding the sum would be, what, by the time you get to the bottom, taking the value, or
You'll get a function at the end for A.
Would that one be cosine?
Are we talking about part A or part B?
Part A.
Part A.
I'm thinking that's cosine.
So I see that. So I see that I have k factorial in the denominator, and for cosine, the Maclaurin series with that.
It has 2k in the bottom.
Bingo.
So would that not work then? You need to have the same.
Bingo. I do need that 2k factorial to match with that.
Okay, so do you just need the top and bottom, the x in the top and the k in the bottom to match? Essentially.
Now,
Okay.
one thing that I would make as a hint, and this would be helpful for A, recall that I could combine the -1 and the x 2k power as -x squared to the kth power. So I could do something similar with that with part A. And I claim once you do that, the Maclaurin series that you'll want to marry it with will pop out very quickly.
Yeah, that's looking like E.
Yeah.
Bingo.
Ooh, not bad.
Yeah, so that's going to be our kind of trick with that is think of what Maclaurin series does similar. Anthony, I know why you chose u dot of cosine.
I thought you could just change. I thought you could then take out the 2 somehow, but I was wrong.
Yeah, not that 2 in the denominator. That has to stay because it's inside the factorial, which means my base will be 2k.
Question about 4b. Is that pi supposed to be an x?
Nope, it's pi.
Okay, just making sure.
But I claim that it's going to be very similar to what we've done. I will let you know that for 4b, we're going to do. So you're going to do the same methodology as we did for the last 2 examples. But I actually evaluated the function at a point. So in this case, what I did was instead of just having an x in there, I let x equal to some number, which means that when I do the work that I did before, instead of an x, yes, it's going to be replaced by some number that pops in.
Okay.
Which means I'll actually get a numerical answer.
Cool.
So I would say still do the work that we've done and figure out what's taking the place of x in my Maclaurin series. What number?
Could we essentially replace that pi with an x, do it, and then plug the pi back in?
I mean, you can. I recommend before you do that, though, because I'm looking at 4B right now. Can I simplify it a little bit more first, and then do what you did? And there's one step that I would do, and it's similar to what I've done there, but it won't be with the negative 1k. So I'll go ahead and write down 4B. So out of everything popping in, I have two things that have the exact same exponent. What two things have the exact same exponent?
Pi in the 6.
Bingo. Which means I could combine that together as pi 6 raised to the 2k power.
No,
And
that
from
is
that-
interesting.
And from that, Anthony, now I can say you can do what you were thinking of. Replace x with a value, but I say it won't be pi.
And I must say, cosine is looking mighty tasty for this one.
It is looking mighty tasty. I do agree.
And I agree. And now just what's taking the place of x in this case?
Pi over 6.
So this whole series is just another way to rewrite cosine of pi over 6.
Did we just solve this one?
Yep.
Oh,
So
cool.
now y'all know, everyone who's in the chat, y'all know what 4B is.
I love how it's on its own page. So you're given all the space, and that's all of the work.
That is pretty epic.
Oh, well then. Yeah, so thanks,
All right,
Unique.
I bet Yannick's really handsome today.
Don't say that I never give y'all anything.
No, it's past
No,
5.
we figured it out. I was the one that said cosine of x, so it was me. It was all
Sounds
me.
good.
I have another question.
All right.
That's it, 4A.
I made a logo for your YouTube channel, but will you actually use it if I send it to you?
Say that again.
I made a logo for your YouTube channel. Can you use it?
Email me the logo first, and I'll see whether or not I'll use it as the logo for the YouTube channel.
All right, because I'm getting very hyped for this channel that's about to take off, you know. Put all your videos public. It's all coming together.
Oh man, yeah, now I need Raid Shadow Legend to monetize to sponsor me, and then I'm good.
Exactly. We'll make this extremely advertiser friendly.
Which I find hilarious because I actually played a few minutes of Raid Shadow Legend because I was curious. It was like,
Really?
okay, what's with all the hype? I did not like it. I thought it was a very awful game.
As most mobile games are.
Oh yeah, I mean that's fair.
Does it have like ads that pop up every 2 seconds?
Oh yeah, oh yeah, and it so
COD Mobile is pretty good though, Yannick.
the only mobile game that I play is it's not even a mobile game. It's a web browser game that I just play whenever I'm I feel like there's truth to that, Unique, with your comment with Raid Shadow Legend. And the game that I typically play on my phone is called Pokemon Showdown.
Ooh,
And I can actually show you what it is because
you got a live stream this on your Surface tablet.
like I said, it's a web browser game. So I mean
Nice.
you could just
Wait,
I'm,
are you
make,
on your own
I'm
mic?
making a game on the computer right now.
Oh, neat. So
It
unique.
should be good when it's done.
And honestly, what it is you form whatever team you want. If you want to go old school, you could go to Gen 1, so back to Game Boy. Because I don't have an attention span, I just do random battle, and it'll randomly generate me a team, and
That's pretty good.
now I'm finding an actual person.
Wow.
Well, I guess I know what he's going to do. He's going to do no retreat. So he probably has. I played this game a lot, so I now have a guess of what they're going to do.
So if I 1v1 you, all go down, or will you?
No, because I like. So I like to play very gimmicky teams.
Do you
So
hustle them? You hustle them where you do really bad the first time, then you put money on it.
Hey, that's
Oh.
pretty good.
Yeah, I have a Bitcoin for that specific reason.
Oh my God.
I see what he's doing. He's now building up his attack stat. So, oh well. Yeah, and that's sort of it.
Nice.
Yeah, this is like the only game I play on my phone, and it's usually like, say, like I am. It's very helpful when I'm like, say, at an airport and I'm waiting for my flight. It is a very great way to kill time.
It is. Oh, would you mind scrolling up for a second? I think I missed something on that blue for 4A.
Okay.
All right, I'm gonna head out. Have a great night.
All right. See you, Anthony. Yep. Happy
Bye.
birthday.
I
Thank
had a
you.
question on number 2.
Alrighty. What's up,
on the
Matthew?
homework. So like I've gotten down to where like I have a a series for it.
Mm-hmm.
But like I'm like about to take the ratio test,
Okay.
and I'm like wondering if there's like a term in front of it, do I include that in the ratio test?
You mean like a common number?
Yeah, like ln of 2 or something like that,
So if that's popping, so if it depends on if it's being added or being multiplied.
It's being added.
If it's being added, then I'm not including it. And that's because I'm doing the ratio test on the series parts of the problem.
So like you would do like ln of 2 plus the limit of it then?
I say ignore the ln of 2 portion. Just focus on the actual terms in the series.
Okay.
Because that ln of 2 being added, that's just kind of extra fluff that's in there.
Yeah. Yeah, that was throwing me off a little bit.
No, fair enough.
And then, like you said, for 4A, the answer is a function, and for B, it's well, we know B, but
Yeah, we know B now.
yeah.
But yeah, the reason why I gave 4B is I looked at other. I have a friend who's also a 1080 instructor, and he seems to like this problem a lot.
Oh, okay, because it just puts together the concepts.
Yeah.
So that would be negative x to the 4th e to the x then, right?
Talking about 4A?
Yeah.
It's not quite 4 times that. So you move the negative and then inside.
Yeah, sorry. For context, it's negative 1 to the k x to the 4k over k factorial.
Yep.
So then if you would to do x to the 4th, put that in front, the term would combine with the x to the k and the e to the x to make x to the 4k.
Oh, I see what you're doing. I actually said this. I would think of at that point, you can go ahead and marry it with the function, because if you already have something like that going on, then I claim that I have a Maclaurin series already popping in. It's just instead of and x is negative x squared.
Hmm. Oh, I see.
Yeah, in this case, I'll leave it at that, which is why I think these problems are helpful, kind of going backwards and saying. And the question I always ask when I have these types of problem, when I was learning it, what Maclaurin series or Taylor series does it look like? And then how can I use properties of power series to somehow marry it with that known Maclaurin series?
I see. Okay, yeah, that makes sense.
And that's sort of part of the reason why I wanted to give an extra day on the homework. Main reason was because Clemson decided to close down online learning yesterday.
Yeah, that seemed pointless.
And I understand why. I'm guessing y'all are not in Clemson right now.
Yeah, we are not.
So the reason why a tornado landed in Seneca and shut down a good bit, essentially did a lot of damage in this area. I actually, fun fact on Monday, my roommates were knocking on my door at 4 a.m. to wake me up and get ready for a tornado because they thought it was coming. I stayed asleep throughout the entire storm.
Oh, wow.
Yeah, I didn't. Yeah, my roommate yesterday afternoon asked me, "Did you hear me knocking and saying your name?" I'm like, no, I was asleep.
Nice. That's funny.
Yeah, I didn't even know a tornado landed near us until I woke up at 6:30 in the morning, and I was like, and then I saw the warning on my phone that said, "Tornado landed. Please seek shelter." I'm like, oh, that happened. So yeah. So my roommates were joking, saying, "Yeah, the tornado actually did. I guess you're gone. I guess that's the end of you." I'm like, yeah, I guess.
Yeah, that's it.
Yeah, I'll have sweet dreams
Oh,
forever.
yeah, funny.
Yeah, so that's why it shut down. Because a lot of areas in Clemson, it affected a lot of people. Some of them are like university professors, so that was why it closed down yesterday.
Yeah, my physics teacher like still doesn't have power.
Yeah, I'm really shocked for me because I live about a mile away from Clemson University, and I still have power, and I didn't lose power. So
Mm.
I was pretty blessed that I still had my power on. Apparently, power did go off because I checked my PS4 and it let me know that it was power unexpectedly turned off. So I was like, oh, I guess.
Oh, yeah, you can always tell because it gets out of rest mode.
Yeah. It like, or like when you turned it on, that happened. And I checked it yesterday mainly because, well, if a storm happened, power probably went off. So this is probably a quick way to check. Oh, yep, it did.
Fair enough. Alrighty, I think that's all the questions I had. But yeah, I also gave you a little subtitle for your YouTube channel called Calculus Stated Simply.
All
I don't
right.
know, it's catchy.
That's right. Okay. So the reason why you struggle instead of struggle is my friends in undergrad, they were very fascinated with my name.
Really?
Mainly because there's a natural alliteration to it.
Hmm.
So a lot of people just said my first and last name together, or a lot of my friends just addressed me by my last name.
All right.
And so my freshman year in undergrad, my friend Tim was asking me how my week has been, and it was like after like a big test. So I was just like, "Oh man, I was struggling this week." He stopped me and was like, "You were struggling this week." And I'm like, "Oh jeez." And that just stuck with our group ever since. And I'm like,
Legend.
"Oh jeez." Yeah. So I just own up to it after that because I'm like, yeah, I guess Punt's not getting away in this group anytime soon.
How elegant. Let's see. Okay. Well, that's all I had. So you guys have a great day.
You too. See ya, Isaac.
All right.
Do you have any questions, Matthew?
No, I didn't know if there was any more questions going to be asked, so I'm heading out now.
Yeah, I'm gonna end it up too. Alrighty.
Yeah.
I'll see y'all tomorrow.
See you tomorrow.